Welcome to Machines That See, Visions from the Front Lines. In this episode, AI Frontiers explores the latest breakthroughs in computer vision, drawing insights from 97 papers published on December 16, 2025. From AI-driven movie making and medical imaging innovation to the hottest research trends and future directions, join us as we uncover how machines are learning to see and understand the world. Today's journey will decode the latest advances in computer vision, highlighting key discoveries from 97 newly released papers. This presentation will spotlight generative models, 3D scene understanding, and medical imaging breakthroughs. Technical concepts are explained in clear language, requiring no prior expertise. We will also take deep dives into 3 especially impactful papers. Stay tuned for an overview of emerging trends, critical challenges, and a look at what's next in the field. Computer vision is the scientific discipline focused on teaching machines to see, interpret, and understand visual content, including images, videos, and three-dimensional scenes. This field integrates artificial intelligence, cognitive science, and engineering, forming the basis for machine creativity and decision-making. Computer vision powers a wide array of applications, such as autonomous vehicles, medical diagnostics, gaming, and more. As the foundation for future digital-human interaction, it is central to building machines capable of perceiving and operating within the world with visual intelligence. The first major theme in today's computer vision research centers on generative models and video understanding. Generative models now create, rather than merely analyze, visual content. For instance, MemFlow, developed by G and colleagues, introduces a dynamic memory system for streaming video generation, ensuring narrative coherence. WorldPlay enables interactive, user-driven creation of virtual worlds. TimeLens, by Zhang and co-authors, allows models to pinpoint specific moments in video content based on textual descriptions. Additionally, Zoom Zero advances targeted video question answering by focusing on the most relevant frames. These developments signal a new era in creative machine vision. A second pivotal theme is 3D scene understanding and reconstruction. This research aims to equip machines with the capability to interpret and recreate the three-dimensional structure of their environment. Notably, the work by Xiang and colleagues on native and compact structured latents introduces the O-Voxel, an innovative and flexible representation for 3D shapes. The ART model reconstructs moving, articulated objects from limited images, while VASA 3D generates realistic 3D head avatars from a single photograph and a brief audio sample. These advances enable the creation of lifelike digital assets for gaming, simulation, and scientific visualization, marking the transition of 3D vision from the laboratory to everyday technology. The third theme encompasses medical imaging, robustness, and multimodal models. In medical AI, revision exemplifies the use of foundation models for retinal disease detection, leveraging large-scale, real clinical data. The adaptable segmentation pipeline demonstrates versatility in analyzing diverse brain tumors. LC-MEM introduces a framework for detecting memorized images, addressing privacy concerns in generative AI. Superclip advances fine-grained image-text alignment. And VIRC provides a system capable of solving mathematical problems by integrating information from diagrams and text. Collectively, these innovations drive improvements in health, safety, and multimodal reasoning. Progress in computer vision is heavily fueled by new datasets and benchmarks. FoodLog Athol 218 advances food recognition for daily life scenarios, while SciNet supports research into Italian Sign Language. The ToomTraf EMOT dataset introduces new capabilities for event-based traffic tracking. These benchmarks are crucial for ensuring reproducibility and real-world relevance of research. By providing diverse and challenging data, such resources enable the development of next-generation models with wide-ranging applicability. Several key breakthroughs distinguish today's papers. MemFlow's memory bank technology enables generation of narrative-consistent videos by dynamically retrieving relevant context. TimeLens, led by Zhang and colleagues, exposes and corrects flaws in existing video understanding benchmarks, setting a higher standard for evaluation. Zhang et al.'s O-Voxel revolutionizes the compact representation of 3D objects, addressing persistent challenges in the field. In medical AI, revision demonstrates that broadly trained models can match or exceed specialized systems. LCMEM establishes new privacy standards for generative AI by identifying memorized content. These findings collectively advance the state-of-the-art in computer vision. The methodologies driving these advances are multifaceted. Transformer architectures are employed to capture long-range relationships within images and videos, while hybrid models combine transformers with convolutional layers to balance efficiency and detail. Generative models, leveraging diffusion processes, autoencoders, and memory banks, underpin modern synthesis of images and video. Multimodal learning utilizes cross-modal attention mechanisms to link images, text, and audio, enabling richer reasoning. Self-supervision and dynamic memory approaches enhance data efficiency and model consistency. The intersection of these techniques allows for robust, scalable, and intelligent visual systems. Our first featured paper is MemFlow, Dynamic Memory for Streaming Video Generation, led by Sihui Ji and collaborators. This work addresses the challenge of maintaining narrative coherence in long, streaming videos by introducing a dynamic, prompt-driven memory bank. The system adapts relevant context on the fly for each video segment, ensuring logical continuity. MemFlow achieves narrative consistency across extended video sequences with only minimal additional computational cost. Its plug-and-play design allows integration with any streaming video generation model. This innovation opens new possibilities for AI-driven storytelling, animation, and surveillance applications. The next spotlight falls on TimeLens, Accurate Video Temporal Grounding, authored by Jun Zhang and team. This paper rectifies the limitations of previous benchmarks by introducing TimeLens Bench and the extensive TimeLens 100K datasets, both featuring rigorous reannotation and high standards. The model employs interleaved textual encoding and a novel reinforcement learning-based training approach. TimeLens outperforms leading commercial systems like GPT-5 and Gemini 2.5 Flash in temporal localization tasks. Importantly, the project publicly releases all data, models, and code, enhancing transparency and reproducibility. TimeLens sets a new benchmark for video understanding in both academic and practical contexts. The third highlight is Native and Compact Structured Latents for 3D Generation by Jiangfeng Xiang and colleagues. This work introduces O-Voxel, a novel, flexible, and sparse three-dimensional representation that captures both geometry and appearance, even for complex and non-manifold shapes. The approach enables the creation of high-fidelity 3D assets at scale. A sparse compression variational autoencoder is employed to efficiently encode these representations. Supporting training of extremely large models, this breakthrough significantly advances applications in gaming, simulation, and scientific visualization by enabling detailed and realistic digital objects. Looking ahead, the future of computer vision is marked by several anticipated directions. Unified multimodal models will blend vision, language, and audio for comprehensive understanding and reasoning. Efficient, adaptive memory systems are expected to support long context tasks, such as tracking characters across lengthy narratives or mapping intricate environments in real time. Emphasis will increase on building robust, interpretable models suitable for deployment in real-world, low-resource settings. The development of new benchmarks and datasets will ensure that progress remains both rapid and relevant. Bridging the gap between cutting-edge research and global impact remains a central goal. This synthesis was created through a collaborative process. GPT 4.1 from OpenAI powered the summarization and synthesis of the technical content. Text-to-speech narration was generated using OpenAI's TTS systems. Visuals accompanying this episode were produced with Stable Diffusion. All content underwent review by a human expert, though minor oversights may persist. Every referenced paper is cited to ensure transparency and academic integrity. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses arXiv.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv.org.